Yes, I think we get it right. And we have this nth derivative function, and in which we are required to find the derivative of e raised to the power 2024x. You see, we are given d 2024 and dx 2024, and the function given is e raised to the power 2024x. So we are required to find this value, and it looks tricky, but it's something we can solve less than 3 minutes. I believe so. But I'm going to take my time and work it out step by step. It's a very tricky problem. It took me a long time to arrive to this point, and but the steps I'm going to use will be very, very essential. Whatever time you come across something similar to this, you'll be able to work it in less than 3 minutes. I trust you, and I hope you can do so. So we are given this. We are required to find the end derivative. So the n here is given as 2024. Before we go straight to the question, and let's find a simple way of working it out. So in this way, let's try to find a way of finding the derivative of e raised to power something. You see, if we're able to find the derivative of e raised to power something, I think we can able to use that relationship to use it to find the derivative of e raised to power 2024 raised to power x. You see, in this function, we say we start solution. So let's say we find the nth function. But before we find the nth function, let's say we find dy dx for e raised by 3x or 4x or 2x, let's say 3x. So that's going to be the derivative of e raised by 3x. Because let's try to find a relation in which we are going to use to find the derivative of these functions. So the relations we are going to use here, let's say we differentiate this, so we can able to map up a system in which we can able to use to find the nth derivative. So the moment we have the nth derivative, it will be easier for us to have the derivative of this function. You see, let's say we are finding the derivative of this e raised by 3x. You see, but in differentiating this value, let's say if we differentiate function y raised by e raised by ax, if we differentiate this y with respect to x is dy dx, differentiate the power always. If you differentiate ax, because when you differentiate ax is a linear term, and anytime you differentiate a linear term, just take the coefficient of that linear, that's going to be the result. So that if you differentiate 5x, the answer is going to be 5. If you differentiate 2x, the answer is going to be 2. If you differentiate kx, the answer is going to be k. So anytime we differentiate the linear function, just take the coefficient of that linear function to be the result of that derivative. You see, so if you differentiate ax, the answer is going to be a, you multiply it to the original function ax. You see, this is what I was saying. So if you have y equals to e raised by kx, so each derivative, just differentiate kx, which is k, and you multiply it to the whole function, which is e raised by kx. You see, these are little steps we need to know, we need to capture, we need to put into consideration when deriving or when differentiating the exponential function. So if we have this, now our case study here is e raised by 3x. How can we differentiate this e raised by 3x? But we need a pattern in which we can be able to use to carefully differentiate this function. I tell you, it's very simple and straightforward. You see, so let's say we take the first derivative. So what's going to be the first derivative of this function? Like I was saying, you differentiate 3x, which is 3, you multiply by the whole function, which is 3x. So this we can write as 3 raised by 1 e raised by 3x. You see? And if we find again the second derivative again, same thing, we differentiate this again. 3 times 3 is 9 e raised by 3x, which can be written as 3 raised by 2 e raised by 3x. I see. If we find the third derivative as well, let's see what we are going to have. We multiply 3 times 9, which is 27 e raised by 3x, which can be written as 3 raised by 3 e raised by 3x. You see the pattern? 1, 2, 3, and so on. So if we do it again, the fourth derivative of this same function, 3 times 27 is something like 81 e raised by 3x, and 81 can be used as 3 raised by 4 e raised by 3x. You see? We can continue. Let's say we stop to the fifth derivative and so on. So the fifth derivative of this function, 3 times 81, is something like 243 e raised by 3x, which is same as 3 raised by 5 e raised by 3. You see the trend? You see, from 3 raised to power 1, 2 raised to power 2, 3 raised to power 3, 3 raised to power 4, and 3 raised to power 5. You see, so you find out that if you want to find the nth derivative of this now, so therefore the nth derivative of this now, this dy dx for this nth derivative just going to be, because since the power here is 3, that's why we are having 3, 3, 3. So it's going to be 3 raised to power n e raised to power 3x. So anytime you differentiate set value, this is going to be the result. You see. So suppose you are differentiating the exponential of 2x. So the nth derivative is going to be 2 raised to power n e raised to power 2x. So this is just the pattern I just tried to generate in a simple way. You can as well choose any number. Because here the coefficient to choose here is 3, you can choose 2. The same thing, you differentiate it, you find the first derivative, which is, you find the second derivative, you find the third derivative, up to the last derivative. You can see the pattern. And that pattern is going to be 2 raised per that. You see, so when you use that one, you can able to arrive to that one. I think, so therefore the nth derivative for this function, the nth derivative for this differential is going to be 3. Since the power here is 3, is 3 raised to power n e raised to power 3. This is the nth derivative for this particular question. Now, let's say again we consider like a function y equals to e raised to power 2x. If this is 2x, let's see what's going to be the nth derivative. For this, the same thing, the first derivative is going to be differentiate 2x, which is 2 e raised to power 2x. We will take again the same thing, second derivative. So you go to 2 times, which is 4 e raised to power 2x. Mind you, this can be written as 2 power 1 e raised to power 2x, and this again can be written as 2 raised to power 2 e raised to power 2x. I hope you are seeing it. And the third derivative again is the same thing, which is 2 times 4, which is 8 with e raised to power 2x, which is same as 2 raised to power 3 e raised to power 2x. And we can say we find the fourth derivative. The fourth derivative, 2 times 8 is 16 e raised to power 2x, which is same as 2 raised to power 4 e raised to power 2x. So this is it. So the nth derivative for this, you can see the pattern is 2. So the nth derivative for set function is going to be 2 raised to power n and e raised to power 2x. This is it. So this is how we can be able to find these functions. You see, so this is just the basic case study. So if we come to the real case study given, the real problem given, how can we find the derivative of this function? You see, so since we generated these two nth functions for e raised to power 3x and e raised to power 2x, just to make the problem look so easy, so now let's try to find a way to arrive to what we are asked to find. Now, so if this is clear, let's try to relate it to the nth function. So in this case, in such case, so if we have the nth derivative, so therefore the nth derivative of dx to power n, let's say e raised to the power 2x. Now we are using e raised to power 2x. Since it is nth derivative, as we have 2, so it's going to be 2 raised to power n e raised to power 2x. This is it. And if we also take the nth derivative of dx to power n e raised to power 3x, is the same thing as we have. It's going to be, the power here is 3, the power is 3, and we take the nth derivative and we take the whole function e raised to power 3x. You see, this is it. So with these two case studies, we can able to find the derivative of this. So now, what is 2024 and dx 2024, and we are given e raised to power 2024x. What is going to be the result? This is the question mark. If we can use these two case studies, we can able to arrive. The n here is 2024 as we have here, and this coefficient of x is 3, and here is 2024. So the result is going to be 2024 raised to the power n, and n is the n derivative, which is 2024, and e raised to power this original function, which is 2024. So this is the result for this value. So the derivative of d 2024 dx 2024 e raised by 2024 equals to 2024 raised by 2024 e raised by 2024x. Don't forget, we need to indicate what is exactly here. So the derivative of this equals to this. So simple and straightforward. I hope it makes sense and we can be able to sit carefully and work it in less than 2 or 3 minutes. Thank you. Stay blessed.